Hey guys, welcome to the CP2 overview, and this is Amos, and this week we'll be looking at characteristics of commercial construction, focusing on building complexity. So initially, let's just cover off a couple of the things around the requirements of the Building Act. We won't go into too much detail here, but the one thing that's important to realise up front is that buildings must be safe, comfortable and support the purpose of their end use. Being safe means also offering means of escape in the event of a fire, and protection of property and life safety. So there's a real focus on those two elements there. Commercial buildings offer a huge and diverse range of uses compared to those of residential. What I mean by uses is what actually goes on inside those buildings. And I'm just looking through a couple of examples here. We're looking at an office setting here. So although the structural frame of the building might still be the same, the fit out and the services that we offer are quite different depending on the uses. This example here shows a shopping mall, and there's quite a difference in the way the structure is designed and the way the building's laid out. Generally low levels but large expansive footprints, as opposed to the office buildings, which are usually the opposite, smaller footprints. We've got a storage facility here, pretty much a warehouse construction, and what we're using here is structural steel. It's quite often the common material used because it's lightweight and it offers us very large spans. Here's an interesting example here of a space frame for a gym. Very large footprint and probably only 1 or 2 levels in a building of this type. So the example that I've shown here is a very rough sketch of what an office building might look like, and these squares here with coloured in are the concrete columns. Okay, and essentially what we have quite commonly is what we call a core in these buildings, and the core is where the main condensed services run and also the main area of transport, okay, or vertical transport if you like. So to put that in plain English, the main services here are the toilets, and we expect to have those on every level, vertical transportation, the lifts and stairs, and of course services like power, data, electrical, HVAC usually run in these service cores here. And you pretty much find that in a common building design like this, that these floor plans are duplicated level upon level. Another important point is the type of building and its location. So it's more likely that in the central CBD we're going to find buildings with small footprints and great height, because land is at a premium there, and you may be surprised at how many levels down some of these buildings go below ground level. If you think of a comparison to something like a building like a warehouse structure, usually 1 or 2 levels, large footprints, big open spans, and we're not going to find those in the city, so we're more likely to find those on the fringes or out in suburbia or rural areas. Let's take a look at building complexity, and really I'm talking in terms of scale. If we look at the two examples here, we've got a house, fairly standard single level residential house, and I've made an approximate number of persons required in the design and build of that. Okay, if you compare that to a commercial building, and this is only really a medium level building, you can see that the number of design professionals required to design and construct that building is significantly more. And what it also adds is that the skill level of those building professionals has also got to be higher. When you consider what those consultants might be, we're talking about structural engineers, hydraulics engineers, mechanical engineers, and we've also got the design architect. Quite often in a job like this that would include a drafting team. What I'd also like to note here is that with a bigger building comes increased complexity, bigger loads, larger foundations, larger structural members. And so really the list goes on, and as these buildings get bigger and bigger, the structure gets heavier, the services we provide in terms of the things I just said, including lifts and escalators, becomes more complex, security systems. So these buildings take longer to design and longer to construct. With the larger buildings, they're subject to higher loads than the smaller buildings. So in terms of the roof area, the rainwater that can be collected, and also snow loads can add a significant amount of vertical load to a building as well. If you think about the size of the building here, it's subject to more loads from earthquakes and wind. So you can appreciate that a building like this, as it gets bigger and bigger and bigger, it just catches the wind like a sail, and the bigger the sail, the faster the boat goes. Hopefully our buildings stay in one place. The point is that the wind loads and earthquake loads increase on a building as its size increases. So I've got an example here of reinforced concrete construction, and I just wanted to show you briefly how the construction of a reinforced concrete frame building goes together. Very basic, but gets the point across. So we start off with foundation pads, and the size of those depends on the soil bearing capacity and of course the load on the building. If the loads are great and or the ground bearing capacity is not sufficient, we may end up sinking piles as well, and that's quite common. On top of that goes the slab, and then so now we've got reinforced concrete columns and a fairly standard beam configuration. Sometimes the beams will go in two directions. In this case I've just shown as one because the flooring will go in the opposite direction. Beams and the flooring, you can see I've left a gap there. Okay, so what commonly happens is the reinforcing is going to protrude out the top of this column and also come out of these beams, and that gets essentially tied together and then concrete is placed in there. The next shot here shows precast floor slabs. There's a range of different types of pre-stressed slabs that are commonly used. You notice also that I've left a gap at the end, so that's where our stairs would go, and or lift, and possibly a vertical serves as shaft. Now essentially this whole kind of design here of, or configuration if you like, of beam columns and floors can be duplicated. Okay, and so we start to have a building that grows based on one configuration, a layout on one floor. Probably a rather boring building, but that's the general gist of how things work. In the case of steel portal frame construction, it's quite different. You can see, for starters, that we are a low vertical level but expansive footprint. And so this is a very common type of construction here. We've got a steel portal frame constructed of, depending on the size, it could be one unit fabricated on site or delivered to site, but quite often it's, depending on the size or the span, it's going to be made up of more pieces. So typically for a very large span we might have this as one piece with a connection somewhere here. This could be another piece and then another piece and so forth. Okay, it really just depends on the span. The type of member we use here is what we call a UB, quite commonly, a universal beam, and it's shaped like an eye in profile. One of the problems, of course, with this type of construction is that it doesn't have a lot of lateral support, and so there's the opportunity for frames to pivot at this point here and tip over. So we get around that by putting in steel bay bracing. Okay, so in this case I've shown it in two bays. These can actually get in the way. If we wanted to have a type of construction where we had windows through here, then we'd have to kind of position the windows to avoid these braces. Another way, of course, is to brace the wall is to have these concrete panels. And these panels are very convenient because they are usually made in a factory, transported to site and craned into position. Not only do they provide a lateral or horizontal support, but they also are the structure and the cladding all in one go. And commonly the reason why we'd use a panel system like this is because we're building on or very close to the boundary, and these panels offer some fire protections. Hey look, thanks for checking out this video, and we'll cover more detail in this in class.